Hello dear students, I am Ajay Karmarkar. Before proceeding further, I would like to give you some suggestions. Please sit with copy pen and watch video completely. And if you find somewhere important, then pause the video, note it and then proceed further. If you find any problem, any difficulties, then please write in comment box. I will definitely solve your problem. And along with, please like, share and subscribe because that can be reached more and more students and I will get the energy. Thank you. Let's move on. What the question says, two disks of same moment of inertia rotating about their regular axis passing through center and perpendicular to the plane of disk with angular velocities omega 1 and omega 2. They are brought into contact face to face coinciding the axis of rotation. The expression for loss of energy during this process is, you have given four options. First option 1 by 4 I into bracket omega 1 minus omega 2 whole square. Second option I into bracket omega 1 minus omega 2 whole square. Third option I by 8 into bracket omega 1 minus omega 2 whole square. And last option 1 by 2 I bracket omega 1 plus omega 2 whole square. Now you can understand by seeing this experiment. Let us suppose there are two disks, they are rotating about some axis and they come to close and now they are combined together but their momentum, angular momentum is the same, and so therefore they are having some losses of the kinetic energy. Then we have to find out the loss of kinetic energy. First off, we have to using laws of conservation of angular momentum, I omega 1 plus I omega 2, and then they are combined together. It means 2I omega, I omega, because omega is the same. So therefore, it can be written as 2I omega. Okay, because when they are combined together, they are moving, they are rotating in same angular velocity. So therefore, here I and omega both the same. So therefore, I omega, it becomes 2I omega. I get common omega 1 plus omega 2 and 2I omega. I cancel, then omega 1 plus omega 2 upon 2 can be written as omega. Is it clear? Then initial kinetic energy when they are not combined together like this, when they are moving on the axis disk D1 D2, then that time we are using initial kinetic energy half I omega 1 square plus half I omega 2 square. Initial kinetic energy 1 by 2 I get common omega 1 square plus omega 2 whole square is the first equation. Okay, when the two disks combine together, the system loses kinetic energy. And then what is the final kinetic energy? Final kinetic energy is 1 by 2 2I and omega square. Okay, rotational kinetic energy 1 by 2, here system moment of inertia of the system 2I and omega square. What is the value of omega? You can see that value of omega is omega 1 plus omega 2 upon 2 whole square. Is it final? Now loss of kinetic energy. Loss of kinetic energy. Initial minus final. What is the value of initial? You can see that initial value 1 by 2 I omega 1 square plus omega 2 square minus 1 by 2 2I and omega 1 plus omega 2 upon 2 whole square. Now solving this portion, 1 by 2 I get common omega 1 square plus omega 2 square. Here 1 by 2 and I get common, then 2 is remaining, and omega 1 plus omega 2 whole square by 2 bracket close. 1 by 2 I omega 1 square omega 2 square minus 2, open the bracket, omega 1 square plus omega 2 square minus 2 plus 2 omega 1 omega 2 upon 4. 2 ones are 2, 2 twos are 4, then 1 by 2 I, taking LCM, get 2 common, 2 omega 1 square plus 2 omega 2 square minus omega 1 square minus omega 2 square minus 2 omega 1 omega 2, bracket close. Then 1 by 2i, 2 omega 1 square minus omega 1 square is omega 1 square, and then 2 omega 2 minus omega 2, then it become omega 2 square, and minus 2 omega 1 omega 2, and upon 2, loss of energy. Then 1 by 4 I omega 1 minus omega 2 whole square. This is the correct answer. Then let's see which option is correct here. The first option is correct. I hope so you understand this question. Again, thank you for staying till the end of this video. I hope so you understand these questions, and please don't forget to subscribe my channel. Okay, thank you. Bye bye. Take care.